Well, you can see what a comet's comb is made of with a telescope from Earth, for example, by analysing the spectrum of the light coming off it. They did quite a lot of that kind of work the last time Halley was here in 1910. The trouble is with that kind of technique, what you're looking at is atoms of the original molecules of gas and dust split up by the sun's ultraviolet radiation and in some cases recombined into different molecules. For example, this picture was taken from Table Mountain in California and shows the comet's positively charged carbon monoxide. And this one, coming now, is cyanogen, or cyanide. Matter of fact, it was that which in 1910 made people think that they were going to be poisoned when the Earth went through the comet's tail. But even the latest Earthbound observations like those are still showing you, so to speak, second-generation molecules. The only way to get at the original parent molecules, as they're called, and to find out, therefore, what the nucleus is actually made of, is to be there like Giotto is. At least we hope it will be. And right now, there are two onboard instruments looking for those parent molecules and at the composition of the dust particles as Giotto moves deeper and deeper into the coma. The first is the particle impact analyzer. Incoming dust particles are detected on a target and split into ions. They're accelerated into an angled tube. And the lightest arrives first. Their flight time is a measure of their mass. The second experiment measures positive ions. Ions are deflected in a curved magnet onto a target plate. Where they fall on the plate tells you their mass.
And now for some views of the ion mass spectrometer. We're delighted that Dr. Johannes Geiss has joined us. Dr. Geiss, how's it going?
It's going very well. We are, of course, very eager to get as close to the nucleus as possible. We're just getting a number of different ions, carbon, oxygen, fragments of water ions. And, of course, they will increase tremendously if we get closer, safely closer to the nucleus.
Well, you wanted to go very close to the nucleus, and indeed you were prepared to risk an impact to destroy the spacecraft. Do you think that was worth it?
Yes, so far we seem to be right, because the spacecraft is still alive. We want to go so close because the molecules which come out of the evaporation of the nucleus, they are rather fast split up by solar light, ultraviolet light. And the closer you get to original molecules. And that's very important to calculate back what you have had in the nucleus.
When can you start getting very useful results? It should be any moment now as the spacecraft speeds
Even now
in.
we have them, and it will of course increasingly be more useful, and we will have a lot of ions. We even have now half a dozen, and there will be more.
So you think on the whole that it's worth it, the chemistry is more valuable than pictures?
Well, I would say they both come together, you know, but certainly the chemistry is very important because these volatile elements, we don't find them in meteorites in large numbers. It's important to see what the ice is made of, water, and you may have organics. Carbon ions we see, so there must be some organic material, yes, but we don't know yet what it is.
Thank you very much, Dr. Geiss.
Thank you.
Well, the situation with the dust impact detector is that we're getting a reading on the average rate at which the particles are hitting. They're still small, and the rate is still relatively low. Sometimes, of course, some of the people that one talks to would say that would give you more cause for concern because it's anomalous. I mean, it's a hole where you'd expect something to be happening. The trouble, as Professor Meadows said earlier about this whole thing, is that nobody knows what's going to happen until it happens. And that's why, to a certain extent, this entire program is a sort of very fast preparation for a very short period of intense activity, which is precisely, of course, what the scientists have been doing for some years, because when Giotto makes its closest encounter, its closest approach, if it survives, it's going to flash by that thing very fast. There's too much danger of what could happen because of the eventual build-up of dust, so there's no recording mechanism on board. So, as some of the scientists themselves have described what's going on, it's going to be very much instant science, instant picture, and instant reaction. And everyone is really waiting, preparing, building up for the moment so that when it happens, they can interpret it as fast as possible, and I hope that means that for you we can do the same thing. Speaking of fast interpretation, Dr. Jim Cohen, your particular field is not one of your particular fields, let's say, is coma chemistry. Is there anything you're hearing tonight that surprises you, tells you anything that we might expect later on this evening about what's going to happen?
Well, the real interest is going to be in the very last few seconds, because most of the chemicals which are studied...
What do you mean by steady? Sorry.
Well, we do radio work, looking at the whole emission from the comet. But, of course, we're only looking at, in many cases, broken up fragments of the most interesting molecules of all, those coming right off the comet itself. And it's only going to be in the last few seconds, really, that Giotto penetrates into the very central layer, where, beyond the sort of contact discontinuity, where you're looking at material which has not been got at all by the sun, material just fresh off the comet. And that's really at that point where the most interest will be in finding what those molecules are.
Do you feel the same way as Jack Meadows, that in your particular area, that there's no way that you can tell what that's going to be like until it happens? In other words, all comets, as it were, are anomalous. There's no rule that fits all of them, and therefore you can't tell in your particular area, for example, that there's a certain build-up, there's a certain tendency, and therefore you could expect certain things. You're still guessing all the way.
Very much so, yes. We're looking at we hope, just fragments of really much more interesting, much more complicated molecules. We might learn something about those tonight.
And Professor Boxenberg, are you, in a sense, capable of helping the chemistry people by getting the kinds of images that will give them any kind of clue at all, or is it still all guesswork? You look up there and you say, well, we're getting second generation molecules, we can't have any idea of what they could be. There must be some theoretical trail back to an original parent that you can guess and then specifically look for.
Yes, of course, the techniques that one uses in just getting images aren't really that sophisticated. You need to get another instrument in line, a spectroscope or something like that. But nevertheless, from the images one can get some good guesses. We may get that tonight.
But again, it will all happen in the very last few minutes.
Yes.
Okay, let's go back to Patrick and see if we're any closer to knowing anything in advance from Darmstadt. Patrick?
Well, in point of fact, we're now within a very few minutes of close-to encounter. We're entering the most exciting time of all. Let me show you how they enhance the pictures. The picture comes through, and then it can be jacked up like this to bring out the detail, as you can see. So the raw picture that comes in bears only a little resemblance to what you finally get. The picture can be improved by out of all recognition. And that is, in fact, how it's done. And another picture has just come in. Look at that. Once again, this is a false color picture, and that red blob must indicate the position of the nucleus. And before very long now, we shall know exactly what that nucleus is. And Giotto at the moment is still going. It's still going, and we're very close now to the vital moment as it speeds inside and makes its closest pass of the nucleus. James.
Well, I mean, it's evident that what we're doing is moving in towards what, in the models before the mission even began, we are moments away from that predicted dust storm that hasn't occurred. So whether or not it's going to come, as Jack Meadows says, suddenly out of the blue, unexpectedly, and therefore a situation for which you can't prepare yourself, isn't it perhaps time to take a quick look at the spacecraft itself to see what it's made of? After all, given the situation right now, it may be the last glimpse that we ever have of it.
Giotto has been spinning through space once every 4 seconds. Its main antenna dish has to remain stationary, beamed constantly towards Earth. Only in this way can the regular stream of pictures and data be maintained. Largely tested in France, Giotto was built by a European consortium led by British Aerospace. The spacecraft is basically barrel-shaped, most experiments and delicate parts housed inside. Throughout its 8-month-long journey, Giotto has been powered by these solar panels placed around the spacecraft's outer wall. And hydrazine fuel tanks feed thruster motors to shift attitude and trajectory in flight. Giotto's quite small for such an immense journey, standing barely 3 meters from base to antenna tip. At the core lies the solid fuel motor that blasted Giotto out of Earth orbit. The structure consists of 3 platforms topped by a tripod. The 2 dust shields and the scientific experiments are housed below the central platform. And under the tripod, the radio antennae to beam that data back to Earth. Altogether, Giotto weighs a fragile 550 kilos as she hurtles into the dust cloud.
Well, you can see there, if we can show you the picture, the flight dynamics picture coming from Darmstadt itself with just over 50,000 kilometers to go and 12 minutes and 20 seconds to go to the time of closest approach. Let me go back to, I guess, I was talking while that film was running there to Professor Meadows again about the fact that we've heard that there are approximately, well, they said that they've had 50 medium-sized impacts that have punctured the exterior shield, and that those things are coming through about 1 every 10 seconds. Is it another case of you saying, well, yes, that might well be, how do I know?
Well, I think it's building up very nicely. With any luck, we could have a disaster in a quarter of an hour.
But I mean, I've heard, I've heard figures bandied around that, I mean, even by Tony MacDonald, who's the head of the dust impact experiment, talking in terms of things like 10,000 impacts a second. We're a long way from that if it's one every 10 seconds, aren't
Absolutely. The thing you have to remember, and I'm sure you do, James, is the size of the impact. This is the vital thing. If you're really talking of number of impacts, there are probably tens of thousands of very tiny things hitting it and have been doing for a long time back. Really tiny things. It depends what size range you're talking about. And as you come in towards the comet, all the evidences are that the size distribution, the upper end builds up.
The bigger.
The bigger bits build up, you see.
But you're talking about what we've got up in space, although it takes a few minutes for the information to get down to us in the form of data or pictures. We're talking about closest encounter point in 4 minutes, just about, aren't we? Oh no, sorry, 11 minutes. I beg your pardon.
11 minutes.
My clock's wrong. But 44,000 kilometers.
You have to remember that there's 10 minutes transmission time, isn't there?
That's true. Yes.
You know, things can disappear and you don't know about them for a while. We'll have to wait and see. But no, at the moment, the build-up is the models assume that there is a distribution that falls off in a generally similar way in all directions from the comet. That's what the models which have been quoted assume. Now, the problem is that that doesn't happen. It falls off differently in different directions, so it depends what way you're going past.
Yes. So, I mean, everything seems to point to the fact that we have no idea no one has any idea what's going to happen in the last few minutes before closest encounter, because the rates will change radically.
But if we could predict what would happen, there wouldn't be any point in us sitting here.
Yes, I suppose so. Yes. Let's go back to our impact. Well, now you see that we're getting this, finally getting this computer-generated data coming back in about the amount of damage that's going on here. And Tony MacDonald, I gather you're out there talking with Patrick right now. Are things hotting up for you, or are you still as happy as you were?
Well, very much so. Well, they were now within a minute or so of closest approach, and we're very glad that Tony MacDonald has taken time off at this particular moment to come and join us. Tony, very near the crisis now. What's the situation?
Well, we're a little bit behind in terms of information coming back, of course. The probe is actually at its probably worst position now, but in fact the data's 12 minutes behind, the data's building up. We know that the shield is lasting. In fact, it's going to survive, and I think the chances for getting past and getting data on the way out are very, very good.
You are, in fact, you think, are now over the worst period?
I think we are indeed, yes.
So, in fact, the shield has really done all and more than was expected of it.
Superb indeed, yes. The dust cloud is, though, very much smaller than we'd anticipated.
Very much smaller, or just marginally so?
Perhaps a factor of 2 smaller.
And what about the actual distance of the dust from the nucleus? Is that smaller as well?
Yes, indeed, yes. It took us, indeed, at least an hour before we got our first impact, so... but very much smaller.
Have you had any major impacts at all on the spacecraft?
Not any which have rocked the spacecraft in any way, and therefore the stability of the spacecraft is good. It's going on the same course, good pointing direction. The camera will get good images.
Well, as we know, you know better than I do, the bumper shield was designed in 2 parts. A thin one to break the emitted particles up and produce them into a kind of a spray, and that principle really paid off.
We've got to evaluate the data before we can really confirm it, but yes, indeed, it looks as if it's doing very well at the moment.
What about the numbers of really large particles? In view of the fact that Giotto has escaped so far, do you think they really are much rarer than was expected?
Well, at this time, the largest particle probably has indeed struck the comet, the space probe indeed, but we don't know yet. We've got to wait 6 minutes for that information.
We have indeed. And of course, you're not quite out of the wood yet, or rather out of the dust storm, because you may be just about passing closest approach now, but then there's the outward journey. Do you think there's any danger of being struck on the outward journey?
That's supposed to be, I think, an easier ride than the inward journey. The comet is a bit shorter on that side because of our approach direction.
And in fact, well, therefore it does seem that all is going to go well.
I think so.
Well, Tony, thank you very much.
A pleasure.
And in fact, we have here got pictures of the control room where everything at the moment is going on. After all, this, after all, is the nerve centre of the entire operation, as you can see. And you can see their picture on the control room screen coming in from Giotto. At the moment, it all seems to be going well, and I imagine there's rather a feeling of considerable relief down there at the moment, because if all the indications are as we believe, then Giotto will in fact survive the encounter and will be able to pass on to possibly to other comets, which is probably something that most people, well, everybody wished, but I don't think people were entirely confident about right up to the last moment. So I imagine down there now that there's all kinds of discussions going on, and the revelation that the dust cloud is smaller than we expected really is, I think, very much of a surprise, because after all, Halley's comet has always been regarded as a very active comet. It's a large comet. It's a very large comet, and we are now just about at closest approach. But, of course, remember, the distance of the comet and the probe from us at the present moment is something like 150 million kilometers. And that's just about the same distance as the distance between the Earth and the Sun. And light and radio waves and messages take something just over 8 minutes to cover that distance. So 8 minutes to cover that distance. And so it won't be for another 7 or 8 minutes that we'll know whether Giotto really has survived. But all the indications are that it has. James.